We're going to continue with chapter 3 and function notation. So here we go. So section 3.3 is function notation. So function notation is just another type of way that we can go about evaluating functions, graphing functions, and so on and so forth. You'll see it's going to be a pretty straightforward, pretty simple lesson. Function notation refers to this aspect right here of f of x. Now what you have to know is you have to know that f of x is the same thing as y, or y equals. So when we see f of x, it's the same thing as writing y. F of x just stands for the function of x. Okay, so this is really the same thing as saying y equals negative 4x plus 7. Now, all you're doing is you're evaluating this function when x is equal to 2 and x is equal to negative 2. So all we're doing is plugging in that 2 in for x. Now, the way that we write this for the first one is we say f of 2. Okay, because what you're saying is when 2 is your x value, what are you going to get? So we just plug that in, negative 4 times 2 plus 7. So f of 2 is equal to negative 8 plus 7, which is equal to negative 1. So f of 2 is equal to negative 1. For our second example, go ahead and plug negative 2 in for x. So f of negative 2, and that's how you read it, f of whatever the value you're plugging in, is equal to negative 4 times negative 2 plus 7. F of negative 2 is equal to 8 plus 7, which is equal to 15. So in essence, what you're getting is you're getting the y value when you're plugging in a value for x. Okay, so that's all you're doing. When it says evaluate, you're just taking that x value and you're plugging it in to get your answer. Let's look at our second example. It says let f of t be the outside temperature t hours after 6 a.m. Explain the meaning of each statement. So now we have to take what's being written here, our algebraic sentence, and we have to turn it into words. Now, we're saying that t is the hours after 6 a.m. And f of t represents the temperature. So this right here is the temperature, and this is the number of hours after 6 a.m. So we need to write this into words now. At this time, we could say something like at 6 a.m. or 0 hours after 6 a.m., which is 6 a.m., the temperature is 58 degrees Fahrenheit. And that's it, okay? Now, keep in mind, this is the number of hours after 6 a.m. So that would be at noon, or 6 hours after 6 a.m. So at noon, the temperature is, and they haven't given us a number here, so we're just going to say n degrees Fahrenheit. I'm going to write this one in a little bit different way. I'll write it two different ways, actually. So here what we're saying, this is our less than symbol, is the temperature 3 hours after 6 a.m. is less than the temperature 9 hours after 6 a.m. If you want to write it a different way, you could say the temperature at 9 a.m. is less than the temperature at 3 p.m. Where am I getting 9 a.m. and 3 p.m. from? Well, 3 hours after 6 a.m. is 9 a.m. and 9 hours after 6 a.m. is 3 p.m. So either way, you can write it either way, but understand the interpretation of that function notation. We'll try these examples in class that are very similar. If you want to take a look at them and do them ahead of time, feel free. Let's look at example 3 now. So in example 3, a little bit different because we're given the function h of x, which is the same thing as f of x or y equals, and they're saying find the value of x for which h of x is equal to -7. So now what they're doing is they're giving us this value here, the h of x. So we're not going to plug that -7 in for x. They're telling me what h of x is equal to, and we have to solve for x. So here, that -7 is being plugged into our left-hand side, into what would be the y equal side. So now we've got -7 is equal to 2/3 x minus 5. Well, now we're just solving this like we would solve any equation for x. But notice the difference between this example and the previous examples where they were giving us an x value and telling us to evaluate. Now they're giving us basically the answer, and we have to solve for x. So we're going to add 5 to both sides. We're going to get -2 is equal to 2/3 x. And now we have a fraction in front of our variable. So hopefully you've remembered how to solve those. We have to multiply both sides by the reciprocal. So by 3/2. That'll cancel out this side. Multiply your left side by 3/2. So we're left with x. And then on the right-hand side, we're going to get -6/2, which is just equal to -3. So -3 is equal to x. Okay, so make sure you're aware of the difference between this example and the previous example. If you wanted to check your work, you don't have to, but you certainly could. Plug in that value. So -7 should be equal to 2/3 times -3 minus 5. -7 is equal to 2/3 times -3 is -2 minus 5. So you get -7 is equal to -7, and it works. Next example here, they're asking us to graph, okay? And they're giving us that function. Keep in mind, f of x is just the same thing as y equals 2x plus 5. Okay, there's no difference between those two. So we can think of this axis here as our f of x axis or our y axis. What are we going to do? We're going to make a table. Best values to choose here, we're going to use -2, -1, 0, 1, and 2 as our x values or our inputs. Now, some of you might already know how to graph this using slope-intercept form. We're going to get there, but for now, we're just going to make a table of values. So, here's our x's, make our table. We're going to plug everything into our function, which is f of x equals 2x plus 5. And then we're going to get our f of x or our y values here. So again, we're going to use the values of -2, -1, 0, 1, and 2. They're the easiest numbers to work with. We've got some negatives involved. We've got some positives involved. So if you're asked to make a table, we suggest you start with those values as your x's. And all we're doing is we're going to plug into our function. So f of -2 is equal to 2 times -2 plus 5. So that's going to be -4 plus 5, which is equal to a +1. So my y value is going to be at +1 here. Same thing, plug in all the rest of them. So 2 times -1 plus 5 is going to be -2 plus 5, which is a +3. So your y value is 3. 2 times 0 plus 5 will get you 5. 2 times 1 plus 5 is going to get you 7. And I'm just doing this for this example so you can see where all these numbers are coming from. But you don't have to show this middle column if you can do that work in your head. So now we've got ordered pairs here, which we're going to plot. So we have the ordered pair -2, 1. We have the ordered pair -1, 3, 0, 5, 1, 7, and 2, 9. And now we can plot our points here. So we've got -2, 1. We've got -1, 3, 0, 5, 1, 7, and 2, 9. This is a linear function. We can connect the dots here, continuous graph. Make sure you have arrows on either side because this graph is going on forever and ever. Okay, so at this point, we want you to make that table of values to create your graphs. Some more try these that we'll do in class. Here's a real world example. We'll take a look at this in class as well. If you want to try to do this on your own ahead of time, the graph shows the number of miles a helicopter is from its destination. On its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight, where f of x is the number of miles. Which flight takes less time? So there's two graphs, there's two flights here. We've got the flight that's shown in the graph, and then we have our second flight, which is given to us by this function right here. Obviously, the first flight takes 3 hours. What you have to determine is how long the second flight is going to take. You can graph it, you can create a table of values, however you want to go about doing it. Try to go ahead and do it, and then we'll take a look at this example in class. Good luck, guys. See you then.